At the beginning of the problem statement that we will solve regarding music generation with RNN implementation. In this first part, I'm going to show you how you create a data set. For this, we are going to rely on the data set that's created by MIT, which is basically an ABC notation for Irish folk song. Well, we can definitely do this for any kind of music, but you do need to have a good data set. So this is a quite a good data set, and we'll start using this. So before we go into the problem statement itself, I just wanted to go over, give you an idea what is ABC notation. So you don't have to know much about it. You just need to know that this is how it's written. So whatever the data set is provided here will have a character like X, that's always kind of the beginning character, and will have a value then T, M, L, and I personally am not very sure what these stands for. But all these characters at the end will something that looks like this kind of tune, and most of us have seen this kind of images or the tunes, right? The musician might know it much better, right? So this is how all these nodes correspond to some character. So what is our job? So see, this is not only just a list of characters over here, but it also contains some metadata, right? So even though we don't understand the metadata, but a model can decipher something out of these metadata. So it tells you about what's the tempo, what's the pace. I did put some notes over here. The title of the song, so that's the title of the song, right? And some different complexities like M, L, C. These are some different complexities that can definitely uh, provide some importance to your music generation, right? So now let's go back to the problem statement. So what is our problem statement? We are trying to train an RNN model to learn patterns in ABC music and use this model to generate a new piece of music. So and so what we have to do is let the model learn about all this music, and then we will provide it a character X, and then it will create a music by itself. Okay. So X is the starting character, and then we'll provide and then it will create a music by itself. At the end of the lab, you'll be able to create a new piece of music. Okay. So let's first go over and load the common library. So for this, we will be, of course, using Torch, PyTorch as a library, and then we will be using the MIT Deep Learning Dataset, and which I will introduce in the next part is WAND-B, Weights and Biases dataset. Okay. Weights and biases to actually track our hyperparameter model. Okay, so let's just wait a little bit and let these libraries load one by one. In the meantime, these are just few bunch of Python code that I use to download the song, and it will actually will take a example song and try to play it. It's a very small piece. I think it's just 15 to 16 seconds. Okay, and then we will convert the ABC notation to audio file and we'll listen to it. And then finally, because I believe there are like 89 songs, and we will join everything together. So our model knows that it's going to predict the next data set for it. Okay. And then because this is mostly data set generation, and what happens is you can already see that this has characters, right? So characters and some values, right? So we need to provide some numerical number to it. Otherwise, we cannot definitely train our RNN model. So I see it's still loading. That's okay. And so what do you have to do for that? So what we have to do is we need to change this character to some index values or some numbers. So for example, so we can actually, let me just take a cell over here. Okay. So maybe like X is representing like 0, then T represents like 1, then A dash, for example, represents something like. So for now, we can just simply stick to giving it some numerical or integer values, let's say. Okay. So that's the code that I kind of, or that I actually wrote over here, and it's still taking some time to build. Okay, not a problem. Let me try to explain this code a little bit in the meantime. So it's very simple. So it's just index and character and enumerate the vocabulary. So vocabulary is actually, so notice here, what is this code doing? So it's actually sorting all, it's making a set of all the songs, right? We have joined all the songs together, and it's picking up all the what do I say? All the identity characters or the characters which are not duplicated, right? So and it's putting it inside a set and sorting it out. Okay. So it's probably sorting it according to ASCII character, for example. Okay. And thankfully it did load. So let's just do. Okay, so there are actually I was wrong. It's a lot of it's a big data set. So 817 songs in this text, and this is how see this is the notation X T Alexander something Z M L, and I'm not very sure about all this. So could be some tempo again and things like that. So let's just convert. So we'll convert it convert a song, and then as I was mentioning, so then we are okay, good. So it's about a minute song. So not all the musics are of this about a minute long, but that's okay. So now we have put this inside a set, so we don't have any repetitive characters over there, right? And then we have sorted it based on ASCII characters. And let's check this. So there are 83 unique characters in this data set, right? So what our model will actually understand is, let's say 3A, B, C. So if it's noticing more of these values, right, just the basic knowledge, right, or understanding, noticing most of these values, then it will understand that if there is 3A, B, then the next character could be C. So that's how your RNN is going to predict the next character. It's always trying to predict the next character. And that's where how we are going to train our model to. Okay. So now let's just run this. And then so I have those 83 characters with some index number. And then so with Gemini you already get some suggestions. So you can use that. So I'm trying to print the characters and the index value. So let's see what it did. So quite good. So okay. So as I was hoping for this, like it's kind of arranging it according to ASCII values, and then it's 0, 1, 2, 3, 4, and then it goes to all these 83 characters. Right? So see, it did pick up all the characters over here. Yeah. Still see some numbers. Yeah, the numbers are also present. So anyway, so these now you can understand that if you have a notation like this, right? So if you have a notation like this, you can individually pick those values as an embedding and put it as 10, 11, 12, 13, or any whatever number it corresponds to, right? And then finally, We can also create a mapping from indexes to character. This is the inverse of character and allows us to convert back from unique index to the character. So, uh, so index to character, and let's just I'll just print and see what is there. So it's simply just making an array of all those workup words. Okay, so nothing big. This is very simple code. Okay, so until now we did vectorization, and the next step is now creating actual data set out of it. So we have a big data. Now we need to create data set which will be used for our training purpose.